Hello, I am Professor Abhishek Das of MIT School of Engineering, and welcome to the third session to the introduction to the logic gates. So for today's session, I will explain the third gate, that is the NOT gate. The IC number is IC7407. Okay, so let's start with the NOT gate. So that is, I will start with from here, that the NOT gate is actually a digital logic gate with one input and one output. As you can see in the diagram or in the symbol, as you can see, A is the one input and one output. Okay. So now this NOT gate is actually operates as an inverter operation. Okay. So it acts as an inverter operation of the input. So in other words, we can say the output of the NOT gate is just the reverse of the input. Okay, so by the truth table, as you can see that 0 is the input and 1 is the output. Okay, and again, when we are giving 1 as the input, I am getting out as 0 as the output, right? So when the input of the NOT gate is true, that is 1, then the output will be false, that is 0, and vice versa, that is when the input is 0 or false, the output will be true or 1. Okay, so by using the gate, we can actually implement, as I have already said in the previous session, with the help of the NOT gate, we can implement the concept of NOR gate, that is a combination of NOT and OR, and also we can implement NAND gate as well, that is NOT gate and AND gate. So combination of NOT gate and AND gate. So with the help of the NOT gate, we can implement NOR gate and NAND gate as well. So it just inverts the output that we get in the OR gate. And similarly, in case of AND gate, if we are calculating NAND gate, so that is NOT and AND, that is we will get just the opposite of the output that we were getting in the AND gate. Okay, so now let us come to the pinout this pinout diagram of the IC7407, where 1 is the input and 2 is the output. Again, 3 is the input and 4 is the output, and then 5 is the input, 6 is the output, and 7 is the ground, that is 0, and VCC is 1. Again, this again 13 is input, 12 is output, 11 is input, 10 is output, then 9 is input, 8 is output. So like this, it happens. So if you are considering the example, just as I explained in the case of OR gate as well. So over here, 1 is the input and 2 is the output, then pin number 3 is input, pin number 4 is output, pin number 5 is input, pin number 6 is output. So pin number 7 is ground, it will be 0 and VCC is 1. Then again 13 is input, 12 is output, 11 is input, pin number 10 is output, pin number 9 is input, pin number 8 is output. So over here, as you can see, it is a 7404 hex inverter. Why hex? Because we are having 6 gates, 6 NOT gates are there in a particular IC, and this is the notch, right? So this marks as the, so this notch will be at the top of the IC. Okay, so in a particular IC we are having 6 NOT gates, right? And the IC number is IC7407. So this is how the NOT gate IC looks like. So 7 pins in one side and again 7 pins in another side. So in total we are having 14 pin IC it is. Okay, and this is the notch of the IC, and the IC number is 7404. Okay, so this is all about the NOT gate. Hello, I am Professor Abhishek Das from MIT School of Engineering, and welcome to the third session of Introduction to the Logic Gates. Now, for today's session, I will explain NOT gate, that is IC7407. Okay, so to explain the NOT gate, that is IC7407, so the NOT gate is actually a digital logic with one input, as you can see over here. So A is the only input and one output. Okay, so X is the output. So the NOT gate is a digital logic gate with one input and one output, and that operates on an inverter. Okay, so it performs the inverter operation of the input, which means that the output of the NOT gate is just the reverse of the input. Okay, so when from the you can see from the truth table that when the input of the NOT gate is true, that is 1 over here, we are getting just the opposite, that is 0 or false as the output, and vice versa, that is when the input is 0, we are getting 1, that is true, as output. So it is just the opposite we are getting. So 1, if you are giving the input, then you are getting 0 as output, and if you are giving 0 as input, then 1 as output. So by this kind of gate, that is NOT gate, we can actually implement a NOR gate and NAND gate as well. So what is NOR gate? So NOR gate is actually a combination of NOT gate and OR gate. Okay, and also for NAND gate, it is a combination of NOT and AND gate. Okay, so for NOR gate, what will be the output for NOR gate is that it will also invert the output that we were getting in case of OR gate. So just the opposite output will be getting for in case of OR gate. And also for a NAND gate, it will just invert the output of the AND gate in case of NAND gate. Okay, so now let us come to the pinout diagram of the IC7404. So over here, as you can see that pin number 1 is the input and 2 is output. And again, pin number 3 is input, pin number 4 is output. Pin number 5 is input, pin number 6 is output. Then GND is the ground, so it will be connected to 0. VCC is, it will be connected to 1. Then again, pin number 13 is input, pin number 12 is output, 11 is input, 10 is output, again 9 is input, and again 8 is output. Okay, so this is actually the diagram example of how the NOT gates are connected. That is, 1 is input, 2 is output, then 3 is input, pin number 4 is output. Similarly, again, pin number 5 is input, pin number 6 is output, 7 is ground, so it will be connected to 0, and VCC will be connected to 5-volt electric supply, current supply. So 13 is again input, 12 is output, pin number 11 is input, pin number 10 is output, pin number 9 is input, pin number 8 is output. Right. Now, this is how this NOT gate looks like, that is 7404. You can see from the diagram or the photograph of the IC, and 1, 2, 3, 4, 5, 6, 7. So each side you are having 7 pins. Okay, so 7 pins in each side. So 7 plus 7, 14 pins. So this is a 14-pin IC, and this is what we call it as a NOT. So this is it must be at the very top of the IC. So this is the left side of the IC, and this is the right side of the IC. Okay, so this is all about the NOT gate. So this is all about today's session.